This is section 4.5, and it's about the fundamental theorem of algebra. And it's stated here, a polynomial f of x of degree n, where n is greater than or equal to 1, has at least one complex zero. So it guarantees that every polynomial has a complete factorization provided we are allowed to use complex numbers. So let's look at some stuff. So a polynomial of degree n has at most n distinct zeros, n distinct solutions. Determine a polynomial of degree 4, so it should have 4 factors, with leading coefficient 2 and zeros of -3, 5, I, and -I. And remember that when you do a factor, we want to put it into x minus the zero or the solution. So here I've put 2 as the leading coefficient, and then x minus a -3 is x plus 3. Then we have x minus 5, x minus I, and x plus I. So that is the factored form of that polynomial. The expanded form, and we're going to be asked to do both. The expanded form means we need to multiply this out. Now this one has a lot of multiplying. Most of your questions don't have that much, but you may have one. So I broke this apart into the real and the imaginary. Over here on the imaginary, we've got an x minus I and an x plus I. That means we're not going to have a middle term. We're going to have x squared minus I squared. And we remember that I squared is -1. So x squared minus a -1 becomes x squared plus 1. So we're going to then multiply this by what we have up here. And what I did here was I used FOIL and did x squared and then a minus 5x and a plus 3x. That gives me minus 2x. And then 3 times minus 5 gives me a negative 15. So I'm going to multiply this one by this one. So first we'll take this x squared and multiply it by these 3. So that gives us x to the 4th minus 2x cubed minus 15x squared. Then I'll take the 1 and multiply by all of these. So we have x squared minus 2x minus 15. These are the only two like terms, so when you combine them, you have a minus 14x squared. The last thing to do is to multiply this 2. So your final answer would be 2x to the 4th minus 4x cubed minus 28x squared minus 4x minus 30. Conjugate zeros theorem. We've talked about this in a previous section, but if it has only real coefficients, and if a plus bi is a zero of f of x, so they tell you that, then you know that its conjugate, its a minus bi, is also a zero. So they always come in pairs. If you know negative 6i is one of the solutions, then positive 6i will be a solution. If you know 3 plus I, then you know 3 minus I. So that's going to come in handy when we start doing some of the work. So let's go look at the problems. So number 1 and number 2 have graphs, and they say this has is a polynomial with real coefficients, and determine the number of real zeros and the number of imaginary. All right, so it says there's degree 2. So if we know it's degree 2, we know at most there's 2 zeros. Is this hitting the x-axis anywhere? No. So that means both of those will have to be imaginary. Number 2 is a degree 3. Now, how many times is it hitting the x-axis? Once. So there should be 1 real and then 2 imaginary. So we choose that. So you're looking for the real ones that hit the x-axis, and the others you'll subtract from the total degree. Determine the number of real zeros in the graph and the number of imaginary. So here, how many times is it hitting? It's hitting twice. And so it's an x to the 4th, so that means there's a total of 4. So we've got 2 imaginary. Number 4, degree 5. How many times does it hit? 1, 2, 3. Take 3 away from 5, so that there's 3 real and 2 imaginary. And this just said, let's see, I don't think that's quite right. So I had to get the thing pulled up, and it should show corrected now. Let's see, there we go. So there are 1, 2, 3 real. That means there should be 2 imaginary, and so that should be F. All right. Now number 5, find the complete factored form and then express it in expanded form. So it tells you the zeros are 3i and negative 3i. So that's pretty easy. X minus 3i, x minus a negative, which will be x plus 3i. So here's our factored form. Parentheses, no comma between them. Then to expand it, we need to multiply those. So we have x squared minus 9i squared. And we remember that I squared is negative 1. So that changes this sign. So we have x squared plus 9. Let's do the same thing with number 6. You have an a sub n is the leading coefficient. So that will be here. But we have zeros of 3, 4i, and negative 4i. So factored form, x minus 3 times x minus 4i times x plus 4i. If I go ahead and multiply these two together, I get x squared minus 16i squared. That I squared changes that sign, so I have x squared plus 16. So now I'm going to take that, x squared plus 16, and multiply it by x minus 3. You can multiply x times both those, or you could do this by FOIL. You can say first one's, that's x cubed, outer is 16x, inner is minus 3x squared, and lastly is minus 48. Okay, let's go down here. Number 7, same idea. Your a sub n is 10, and your zeros are here. So factored form would be 10, and then you put those in your factors. And just like that one in the lecture notes, we've got to do both parts. So here's the real part that ends up being x squared minus 9. Here's the imaginary part, which ultimately becomes x squared plus 25. We can do FOIL, and we get x to the 4th. Outer is 25x squared. Inner is minus 9x squared. And then last will be minus 225. We have to bring in the 10 and multiply everything by that. So your final answer is here. And that would be in the B part. Number 8, find the zeros given that 1 0 is k. All right, we've done one of these in a prior section, I believe. So the zeros are given, that you're given is, you have 4/3. So let's do synthetic division on this. Write down 3, negative 4, 12, negative 16. Bring down the 3. Now we're going to multiply. 3 times 4/3 is 4. Add, you get 0. That times 0 gives you 0. Add, you get 12. 4/3 times 12 is 16. And so we'll put 16 there, we'll add and get 0. And you should always get a 0 if you're dividing by something that they say is a factor. You should have no remainder. So then we convert that back to quadratic because it was cubic here. So 3x squared, no x, plus 12 is 0. 3x squared is negative 12. Divide by 3, you get x squared is negative 4. And that means your answers are plus or minus 2i. In here, you want to use the one you're given, put that in as an answer, and then the 2 that you just found. Number 9. Now, number 9, we're going to be doing it backwards of what we were doing in several in the middle of the assignment. In this one, we're going to find the zeros. We're given the equation. So go over here just like we did right here and say x squared plus 9 equals 0. X squared is negative 9. X you take the square root both sides, is plus or minus 3i. So the zeros are 3i and minus 3i. To put that in factored, we just put it in parentheses, x minus 3i, x plus 3i. Let's do the same thing with this one. It's a little bit different on the solving. So we take the given function and set it equal to 0. Now on this one, this is not like we can't add something to the other side and solve for it. We have x in both terms. So let's factor out 12x. When you take it out of this, you're left with x squared. Take it out of this, you're left with 1. So we have two factors. 12x equals 0, and this thing equals 0. So this one ultimately is equal to 0. This one's x squared equals -1. Take the square root, and you get x is plus or minus I. So the zeros are there. 0, positive I, negative I. The factored form, you put the leading coefficient that was here originally, put that with the x, because that's right there. And that's our 0 solution. And then we have x minus I and x plus I. All right. Number 11 is a little bit different as far as factoring. It says find all the zeros. Well, when you have 4 terms like this, often you can factor by grouping. And that very last term that I have there, right here, should have a parentheses around it. And I'm going to put that in right now. So take the first 2 and the second 2, and then we'll just factor out of each one. So in this one, let's take out x squared. That leaves x minus 4. You're going to hope that you can factor out something and have another x minus 4 here. Well, we can. We take out 9, and we're left with x minus 4. Now, when you're looking at this, one way to think about it, what's common in both those pieces? X minus 4. So if I pull out x minus 4, what's left? X squared plus 9. And the reason we did all of that rearranging up here, we're just adding and subtracting. Now we're multiplying, and those are like factors. So we can take this one and say x squared has, if you put x squared plus 9 equals 0, and then you get x squared equals -9, that gives you plus or minus 3i. This one just gives you x equals 4. So several things about finding the zeros and putting in factored form or expanded form, but I think that should get you for 4.5.